through this first little stuff, then finding a resultant is finding components that a resultant came from. Right? So let's say that I had a vector 15 meters per second at 30 degrees. 15 meters per second at 30 degrees. Is everybody good there? We would all agree that there's going to be some x vector and some y vector that is perpendicular to that I could place that would give me that 15 as a hypotenuse, and they would have an angle of 30 degrees. Everybody good with that?
Yeah.
So how do I go about finding those? If I know this is my angle of 30 degrees, right? If I drew this to scale and measured that 30 degrees, I could just measure and measure, correct? Just like I did before. Do I want to do that?
No.
Probably not. Probably too much. After 10 minutes of it, I'm pulling out what little hair I got left, right? So how can we go about trying to find that side, the y component?
Well, you know that's perpendicular.
They are perpendicular.
That's 90.
So 30 equals
I didn't hear what you said.
like sine of 30.
Use the sine function, right? Sine of theta should be Vy over my hypotenuse, which would be 15 meters per second. Is everybody good with that? I know theta is 30, so I get sine of 30 times 15 equals Vy, which should be like 7.5, I'm thinking. Because isn't sine of 30.5? Yeah. So that's just me. Then what about the component in the x direction? You could use Pythagorean theorem, but it'd be using something you measured or calculated, right? Is that necessarily the best choice?
No.
But I could use cosine, right?
Yeah.
Cosine of 30 should be equal to my x component over 15. And then I take 15 cosine 30 and get Vy.
Cosine 30 is root 3 of 2.
And get like 13.0. Is everybody good?
Yeah.
So I have 13 meters per second east and 7.5 meters per second north. Right? I drive my boat east at 13 meters per second. The water flows 7.5 meters per second north. What's my resulting velocity? Right? Is everybody good with that?
Mm-hmm.
That would be sort of the example. But here, I'm in a boat going at 15 meters per second at 30 degrees. Right? How fast is the water? How fast is my boat? Does that make sense? Everybody good there? Now, one thing we want to mention or realize when we, based on this idea, cosines involve the x direction, correct? And sines involve the y. Right? Your calculators are set up to recognize that, to realize that. If I had a vector (50 meters per second) at 215 degrees. I'll do that one. To 205 degrees. What would the x and the y components be? Let's do that now. How could I calculate the x component?
Subtract 1.
Okay, I could look at finding this little angle right here, which would be 205 minus 180, which should be 25. Is that right? Okay. And if I take cosine 25, I get 0.906 times 50.
Mm-hmm.
And I get 45.31. So Vy is 45.31.
How did you find that?
cosine 25 times 50 should equal Vy. This is the adjacent hypotenuse. So cosine should relate those adjacent hypotenuse, right? Here's my small angle. Does that make sense? Okay. What about my sine? For my y component? Sine of 25 times 50 should equal Vy. It should be 25 meters per second. Is everybody good there?
We got 21
Okay, 21 where?
for VY.
Oh, it's 25, sorry. 25 degrees, I don't even know what the cosine and sine of that is. Yeah, it should be like 21, my bad.
There.
Somehow I had 30 stuck in my head. Are those correct? Yeah, they are?
No, that's been negative.
Right. From the origin, which direction did I move for x? So that's got to be negative 45, and I went down, which has got to be negative 21, correct? Perfectly fine to do it that way, but you got to remember, quadrant 3 is negative, negative. If it were in quadrant 2, I'd be negative x's, positive y's. However, if you just take the angle they give you and say cosine 205 times 50, you get the negative already. Negative 54.31.
45.
Sorry. Yeah, that would make sense, 45. Been a long day, people. It's been a long day. And here I'll get negative 21. Automatic when I take sine of 205. Right? Your calculator's set up to deal with that unit circle already. All right? So if you end up with, an angle over here at 118, cosine 118 will give you a negative value. And your calculator knows you're going in that direction. And your sine of 118 would be positive. And you come out with positives where you're supposed to be positive. Okay? Then that leads me to one final point. If you're plotting perpendicular components, like 10 north and 6 west, if you plot that 10 north and 6 west, that's going to be your VR, correct? The interior angle you can find here is this one, right? But your opposite side of that, you'd be looking at sine of an angle, right? And that sine involves an x component. X components are related to cosine and y. So whenever you're plotting perpendiculars, go east-west first, then north-south. Okay? East-west, then north-south. And it'll allay some confusion that I guarantee you will result if you do not do that. Any questions? One more I want you to try on your own. .35 meters per second at 127 degrees. Find the x and y components of that. How can I find the x?
Cosine 127 times 35.
cosine 127 times 35. And what about the sine, or the x? Sine 127 times 35. And what should those equal? What do those equal?
Negative 21.06 for x.
Negative 21.
28.
For, yeah.
For y.
28. Is that good? 28 point what?
No, it was 27.695.
Okay, so 28.0 and 21 point what, Jerry?
1.
21.1. X. Y. Is everybody good there? Yeah.
Can you use like I did sine 53 times 35 because
Which would
I
be
did-
here.
yeah, I did 180 minus 127.
Yeah, you can do that, but then you got to remember you're in quadrant 2. Now your x's have to be negative.
Yeah.
That's going to be on you,
Okay.
right? And the tendency is to say, oh, it's positive 21, positive 20, to forget that that's negative.
Do the negatives have to? You have to put them in while you're solving it, or just at the end? To put it?
If you use 53, you just put them in at the end,
Okay.
right?
Yeah.
Or when you got your cosine 53, you hit the negative and then times.
Yeah. Okay.
But if you just use whatever angle you're given, 487, it'll give you the right sine cosine every time.
Okay.
Because it knows
Yeah.
487 is more than
Okay.
one time around back into quadrant 2.
Okay.
Questions there?
No.
Awesome.